Hey there kiddos, welcome to another video. This is for Module 1, Lesson 3, and it's for Eureka Math for Grade 5. The objective today, and this lesson is a doozy, it's to use exponents to name place value units and explain patterns in the placement of the decimal point. Now, most 5th graders are probably going to look at this objective and say, I don't even know what an exponent is, let alone how to use it. So I have a little bit of background information, very, very important, because most 5th graders will not be able to start this lesson or do it without some sort of intro. Factors are numbers you multiply. 4 is a factor here because I'm multiplying it by 5. This sign here, this operation sign, means this has now become a factor and this is a factor. Exponents are not factors. It's a little number, okay, that's going to float above to the right up on the corner of the base number. So what you do is you call this number, if I have 4 times 5, these are just my base numbers, okay? Now, these are just factors. 2 here is a base number. 3 is this little tiny number that's floating above and to the right of the 2. The 3 is an exponent. Now, what does that mean? It does not mean that I'm going to multiply the 3 times the 2. No, 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 no. Exponents are not factors. Please write all these notes down. You want to have these notes. You'll have to occasionally refer to these notes throughout the year. You have to understand what exponents are. Biggest mistake by far, students will look at this and they want to multiply. They say, oh look, I know how to multiply and here's a 3, let's just multiply it. Please don't. The 2 is a base number. What it means is you're going to take this number that is the base, the 2, and you're going to multiply it this many times by itself. So the 3 tells you how many times to repeat it. Easy peasy, right? You'd think so. So in today's lesson, we're using tens as our base, okay? So our base number is going to be 10. So whatever the exponent is, you're going to have 10 times 10 times 10. So this is what exponents are. Now let me show you a quick little sample of some other notes that you can take down if you want to pause the video for a couple minutes just to practice, because this is how exponents are solved. This right here is a problem unto itself. That means this is solvable. 2 cubed, which is what the 3 is as you say it. I'm so sorry, I didn't do that. It's not my fault, but 3 means cubed, and we'll get to that later when we do geometry. Anyway, it's 2 times 2 times 2. Again, write the 2 3 times. So here's 1 time, here's 2 times, here's 3 times. Now multiply. 2 times 2 is 4. But take that product and multiply it by this other 2 that is waiting to be multiplied. 4 times 2 is 8. The answer to 2 cubed, or 2 to the 3rd power, is 8. I know this is all new. Here's another one. 8 times 8 is equal to 8 squared. 8 times 8 is 64, so 8 squared equals 64. Here's another one. 5 to the 4th power is 5 times 5 times 5 times 5, because it's 4 5s multiplied all together. So you start multiplying. 5 times 5 is 25. Then you have to multiply 25 times 5, which is 125. Then you multiply the 125 times 5, and then you get 625. So this little thing here, this tiny little way to write this, actually is a huge problem that has a really big answer. So when people talk about exponential growth, this is why, because exponents are really multiplying the base number by themselves. Now, here at the bottom of this page, for our lesson today, 10 is going to be your base. Now, if I have 10 squared, and again, I didn't do it, I'm sorry, but 2 is what you say squared when it's 10 to the 2nd power. Nobody really says to the 2nd power. You just call it a square. So that's going to be 10 times 10. So 10 squared is equal to 100. 10 cubed, 10 times 10 times 10, looks like this. 10 to the 4th power, and that's how you kind of say it as your numbers get bigger. It's just to the 4th power, to the 5th power, to the 6th power. You start writing them all out, and this is what we have as a warm-up in the teacher's edition. So I have one more set of notes. I know it's a lot, and again, pause it, write everything. You'll be so happy later when you can look back and have all these answers. So if this is exponential form, 10 squared, 10 cubed, 10 to the 4th, 10 to the 5th power, this is what you say. This is what you would write to expand the form, 10 times 10, 10 times 10 times 10, and so on. And this is what you would get when you solve it. Okay? Again, a little bit more. If I'm multiplying with 10, I can look at the number of zeros. I can use an exponent to represent that number instead of writing it all out. And I can understand that if I have 10 as a factor times 10 with an exponent, that really the exponent means how many tens I'm multiplying. The other part of today's lesson that is going to be a little bit of a challenge is taking what we did in lessons 1 and 2, which is understanding how to multiply by 10, 100, or 1,000, and to shift the digits. But now, instead of saying shifting the digits, shifting left, shifting right, shifting left, shifting right, what we really are going to be doing more of is just moving the decimal around so that when we place it, that will automatically have shifted the digits. Now, you're probably totally confused and you're like, oh, good heavens, it's so many notes. But after you write your notes, we'll get into the book and I'll show you some answers and we'll go over it together. So, for example, when we talked about whole numbers and multiplying, and I would say, well, you can add the zeros at the end with whole numbers, but if you have a decimal, you can't just tack 3 zeros on the end, because if you multiply 3.4 times 1, you would just get 3.4. So you have to shift the digits so that the 3 is no longer in the 1's place. This needs to be 1,000 times bigger, so the 3 has to move over 1, 2, 3 places so that I would end up with 3,400. Okay? In the same way, we're going to be using division. They throw it all at you in the same day. We're going to take a number, we're going to divide, which means you're shifting the digits to the right. How many times? The 2 will tell you. Okay? 10 squared is equal to 10 times 10, which is 100. So this is going to be a 2-position shift. The 7 is going to move 2 positions right. But again, instead of saying the 7 will move 2 positions right, what if you take the decimal, you move it over, you place it here, okay? Then you can see that I have 0.071. The 7 has shifted 2 positions right, and it has the proper answer for the place value. So it's so much in these first 3 lessons. It's really horrid for children. But anyway, this is what they are going to do for us. The last thing that we do in today's lesson is to find a pattern. And so they'll give you 2 or 3, maybe in a row, maybe they'll skip some. So you have to identify between 2 that are adjacent to each other and what the pattern is. And so if I see a shift, look at the decimal, it went 1, 2 places to the right. That means this little number became 100 times bigger. So the pattern is to multiply by 100, which is equivalent to 10 squared. Now that's a huge introduction. That was like 9 minutes. So let's get into the book so we can finish our lesson. It's a little bit quick because you're writing just the answers up here, but we have a lot of explanations, so let's jump in. Write the following in exponential form. That means you have to use this format, okay? Now, if you're not comfortable with this yet, which who would be, use this and then convert it, okay? So here we go. If I have 10,000 and I want to have a 10 as my base, how many zeros do I have? You can count and see that there are 4 zeros, okay? If you wanted to prove it, and you did 10 times 10 times 10 times 10, 10 times 10 is 100, 10 times 10 sorry, 100 times 10 is 1,000, and 1,000 times 10 is 10,000. So you can prove it if you want to, but we don't really want to take up all that time and space, but just know that you can definitely do that. For B, how many zeros are there? Okay, so we're going to have a matching exponent to the number of zeros. How many zeros are there here? Well, there are 2 zeros and there are also 2 tens. So this is my base, and so my exponent is 2 because there are 2 of them. Okay, now how many zeros are here? Again, we want to use 10 as our base. So the total number of zeros is 4. That's your exponent. How about in this one? This is 1,000,000. What if I didn't want to write out all those zeros? What could I call it? How many zeros are there? 6. How about in this one? If I have 10 as my base, if there's a 10, how many zeros are there? Count them. 1, 2, 3, 4, 5, 6. So 10 to the 6th power. You can write all these out and prove it if you feel like it. You probably don't. You're probably tired of writing. Anyway, let's keep going. Write the following in standard form. That means you're going to solve it, okay? Like in your notes that you took copious notes and you got all the answers. So now I actually have a power of 10, so I need to multiply this answer by 9. So how many zeros are there? There are 3. So I'm going to take my 1,000 and I'm going to multiply that by 9, and I'm going to get my answer of 9,000. So see, it's not too bad once you get going. How many zeros? 4. So I have 10,000 times 39. And definitely write all this stuff. You don't have to just write the answer. If just the answer doesn't help you understand it, write this whole thing out. Once you have 39 times 1, any number times 1 is that number, then you have your 4 zeros. See how easy that is? Match this to this. How about for C? Watch out. We're dividing now. So we're not going to be shifting to the left. We're going to be shifting the digits to the right. So 10 squared is equal to 100. And so we're going to be making this 100 times smaller, or 1/100th of the value of 7,200. It's 2 shifts to the right, which means we will get 72. If I divide by 1,000, it's going to be 3 shifts to the right, which means I'm going to drop off all 3 of those. And I end up with 7,200. Move up here. I have multiplying by 1,000, which means this is going to be 3 shifts to the left, which means if I move my decimal to the right and plop it in, I end up with 4,025, and the decimal is here. You don't have to put the decimal. I'm just showing you that's where it is because this is now the ones place. How about this one? 10,000. And then that is going to be multiplying. So this is going to be shifting to the right. Now don't just tack 4 zeros on the end. That wouldn't change these, but these have to shift. So if I shift the decimal 2 times, that's only half of what needs to be done. And then I have to shift 2 more places to get all these out to where they need to be in the greater place value positions. 10 squared is equal to 100. I'm dividing here. That means this 72 and 5/10 has to be 100 times smaller, or shift twice. And that will put the 7, instead of in the tens place, it's going to be over here in the tenths. And for this one, again, 10 squared is equal to 100, which is 2 shifts. And so the 7 and 2/10 has to go 2 times to the right, which would mean we have 7 in the tenths place now. So if you have your explanation that you need to write, first of all, we have the answers for problems 2A through D. Explain the pattern used to find an answer when you multiply or divide a whole number by a power of 10. So if I have a whole number, these are all whole numbers. 9 is a whole number, 39, 7,200, and 7,200,000. No decimals. No decimals. Big difference. Circle that. It's a big difference. Okay, so whole numbers only. Whole numbers only. You can basically add the zeros to match the exponent, and you're shifting the digits left, okay? Shift left. So for dividing, that's for multiplying. For dividing, whole numbers only. That's an abbreviation, nums. And it's going to be to remove zeros or shift right to match the exponent. You might have to pause the video to get all that written because sometimes I go fast, like today I'm going a little bit fast. Think about the answers to problems 2E through H. Look at this factor, decimal. Look at that one, decimal. Look at this one. This is division now with decimals. So explain the pattern. Again, we're shifting, and if you multiply, you're shifting left, and again, you're looking at the exponent to tell you the number of shifts. Okay? So you must shift the digits. I'm going to move it up just a bit so I can write better. According to the exponent. Okay? Now, if it is multiplying, you're going to shift the digits left, and that means you're essentially moving the decimal right. Okay, I know that'll probably confuse a whole bunch of people, but I'm telling you, if you shift the digits to the left and the decimal stays where it is, then it looks like it has moved to the right. If you're dividing, you shift digits right. Okay, so that they're in lower place value positions. You have to match the exponent. Let's move on. Turn the page. There's a whole bunch more on the back. And this is where we're going to work with the patterns. Like I said in the warm-up, you have to identify and complete the pattern. Well, you can't complete it until you know what it is. So look at the difference between two adjacent numbers, okay? Oops, not the A. Look at the difference between two adjacent numbers. I need to know what the difference is in order to identify the pattern. So if I say here, I've got 3/100ths, and then just next door, I have 3/10ths. So the 3 shifted left 1 position. So the 3 got bigger by 1 place value position. So what happened between here and here? If it got bigger by 1 place value position, that's a change of a 10. And when it gets bigger, we're multiplying. So you have to identify what the pattern is, what's needed, so that you can then apply it. So if I take 3/10ths and I multiply it by 10, what would I get? And if it's going to get bigger, it's going to go 1 place value position to the left. Then you multiply by 10 again just to prove it, and yep, 3 times 10 is 30, so hooray, I've got the correct pattern. Now take 30 times 10, what do you get? And 300 times 10, and what do you get? That's right, 3,000. So fill in those blanks. If you want to challenge yourself, pause the video, try to complete these, and then turn the video on and check your answers. Here's the next one, 6,500,000. Then it reduces in value. The 6 goes from the millions place to the 10,000s. Okay, that's going to be not here in the 100,000s, but here. That's a shift of 2, which is 100, or 10 squared. That's my factor, or am I multiplying or dividing? It's a factor if you multiply, but I'm actually making it smaller. So I'm going to divide. This is my divisor. So I want to divide by 100. So if I'm going to end up here, I've got one in between. So 65,000 has to have a shift of 2. So this is going to go right there, and it's going to be 650. And then when I divide by 100 again, the 6 would end up 2 shifts over into the ones place, so that's correct. Now the 6 is going to move 2 shifts to the right, so it'll be in the hundredths place. I almost said tenths. Nope, this is the tenths. It's in the hundredths place. Okay, so 0.065. Now, this one, you know, they gave you the 2 that were adjacent, but we have to go over here to find 2 that are adjacent. So what's the difference between these 2? If I'm moving to the right, I have 94 and 3/10 being reduced to 9 and 43/100. So when I go this way, I am reducing the value of my 9. If you just look at one digit at a time, it's going from tens to ones. So if I go this way, I can divide by a 10. But if I go this way, because now I've got this option to go both ways, if I go this way, it's getting bigger. And so if I'm not going that way, dividing, then if I want to go this way, I multiply by 10. So now you can fill them in on both sides. 94 and 3/10 times 10 would shift that one time so that you'd have 943. And if I go to the left again, I would have 9, 4, 3, 0, and another 0. Because when I multiply by 10, I'm shifting the digits to the left. But if I go down here to the end, then I'm shifting the digits to the right. So here it went from the tens to the 9 goes from the tens to the ones, and now it should be in the tenths. So just look at the pattern and complete that. The next one, 999, 9,990, 1 0, 99,900, 2 zeros. So I have the same base number. This one's pretty easy. I've got 1 0, 2 0, 9, 9, 9, and 3 zeros. 9, 9, 9, and 1, 2, 3, 4 zeros. 9, 9, 9, and what? 5 zeros. You're right. So be careful with your commas. You have to place them to help you read the numbers. Okay? So it's going to be 1, 2, 3, comma. 1, 2, 3, comma, 1, 2, 3, comma. This has 2 commas. 1, 2, 3, comma, 1, 2, 3, comma. And you should have 99 million on the far right. Last one here for filling in the pattern. I've got 3 to choose from. You can look at the relationship between them. So if I go to the right, I have 7 and 5/10. And then when I go to the right, the 7 moved from the ones place to the hundreds place. So that's a shift of 2, and it's getting bigger. So this is times 100. So now just double check. If I multiply 750 times 100, do I get that right answer? Yes, I do, because I have 2 zeros here. So I'm going to take 75,000, and if I have 75 and 3 zeros, which is basically what we're looking at, I need 2 more zeros. Put your comma in. Then, if I have 7,500,000, oops, I'm sorry, don't put the comma there. If I have 7,500,000, I'm going to put what I had before. Okay, so I've got 7, then the 500, then the 3 zeros. I need 2 more zeros in order to complete the pattern. Now you put your commas in, and you should end up with 750 million in the last entry. Now come back to the beginning. If I'm going this way, instead of multiplying, I'm going to divide by 100 to go this way. So take your 7 and 5/10, divide by 100 so that you can shift the digits to the right. So instead of the ones, it goes tenths, hundredths. There you go. Okay? Now, I have a lot of writing that I could do here, but I want to wrap up the video, so I'm gonna place it, read it, and then we'll go over the answers because this is getting pretty long. So, here we have, how do you find the unknown numbers in set B? So if you look at set B, you've got 6,500,000. So you have to find the pattern or identify the pattern between two adjacent entries. That's what I was talking about. Here, it's going to be like minus 2 zeros. You're taking 2 zeros away. 2 zeros are equivalent to 10 squared or 100. And if you're taking them away, it's divided by 100. Write this down. For G, if you're going to explain how you find the unknown numbers in set D, that's with all the 9s. And I said, oh gosh, this one's really easy. We just went from our base 999, 1 0, 2 zeros, 3 zeros. Basically, we just added a 0. So I just tacked on, because it's a whole number, at 2 zeros, 3 zeros, 4 zeros, 5. Write that down. The last part is interesting and important. It's kind of like to help you prove that you understand it. A lot of the time in this book, they're going to write common errors and then say, hey, fix that. So Shawnee made this error and Marlon made this error. So what are the errors? Well, let's take a look. Shawnee took 10 to the 5th power and multiplied 10 times 5. And Mrs. Setna said, don't multiply the exponent. For crying out loud. Shawnee. Rookie error. Okay, don't multiply by that. You have to write out 10, 10, 10, 10, 10, and multiply the 10 that many times, which you should end up with 100,000 if you fix it. Then Marlon wrote 2 5/10 times 10 squared and got 2 5/10. Again, that's the same answer. That is the same. That is the very same thing. Those 2 zeros there do not change the value of the 2 5/10. They don't. Okay, so this is equivalent to this. That didn't multiply by 10 squared. So Marlon just tacked the 2 zeros, the 2 from the exponent, zeros on the end, but that doesn't change the value at all. 2.5 is equal to 2.5. It's the same. So you need to fix it by shifting twice. So 2.5 shifts left to 250, and that's how you solve it. Woo! It's a long one. I'm so sorry, but yeah, exponents, ugh. Click subscribe, come back again. I hope these videos are helpful, and we will see you on the next one. Bye now.